chapter, we are going to study nature of work and heat. First, let us see nature of work. In your lower classes, in mechanics you have studied, work is the energy by which a body is displaced by a certain distance by applying a force on it. So according to mechanics, work is given as force into displacement. Work W is equal to force F into displacement D. In thermodynamics, the work we consider is known as pressure volume type of work, which is written as PV type of work. Now what is pressure volume type of work? Suppose I take a gas and if I carry out its expansion or compression against some constant external pressure, then whatever amount of work is done, that is called as pressure volume type of work. Now it is realized that work is nothing but product of pressure and volume. So let us prove that work is product of pressure and volume. We have studied that in mechanics, W is equal to F into D. Call this as expression number 1. We want to prove that product of pressure and volume is work. So let us take P into V. What is pressure? Pressure is force per unit area. Let the force be F, let the area be A. So pressure will be equal to F upon A into volume. So PV will be equal to F upon A into V. Therefore, PV will be equal to F upon area. Area means distance square. Let the distance be small d. Volume means distance Q. So I am substituting area as d square and volume as dq. Now only one d will remain. Therefore, PV is equal to F into d. Call this as expression number 2. So in place of F into D, in expression number 1, I will substitute P into V. Therefore, from 1 and 2, I can say that W is equal to P into V. So work is product of pressure and volume. Now let us see the nature of heat. Let us assume that there is a system which is at temperature T1 and its surrounding is at temperature T2. Let us assume that T1 is greater than T2 means the system is at higher temperature and the surrounding is at lower temperature. Due to difference in temperature, there will be an exchange of energy between the system and surrounding. More precisely, system will give away energy to its surrounding, and this energy which is exchanged due to difference in temperature is known as heat. Now let us understand the sign conventions for heat and work. We know that heat and work are different forms of energy. So if the energy of the system increases, then it will get a positive sign, and if the energy of the system decreases, then it will get a negative sign. Suppose there is a system which absorbs heat, means energy of the system is increasing, so Q will have positive sign. If there is a system which releases heat, so energy of the system decreases, so Q will have a negative sign. Similarly, during the process of expansion, the system is utilizing energy to push the piston up, so energy of the system decreases and work will be negative. During compression, the surrounding is utilizing the energy to push the piston down, and this energy is gained by the system. So energy of the system increases and work will be positive.